Hello everyone. In this session, let me continue few more concepts based on the floating point representation. As in the previous session, you have already come across representing a decimal number. Given a decimal number, we are going to represent it in terms of what we say machine number. Right? In the sense, given number will be in the form of decimal number. We are going to represent it in terms of hexadecimal. This is what we have learnt in previous session. If you want, you can cross check it. Now in this session, let me learn the reverse concept. But anyhow, this question up to here, it was not asked in any of the examination, but if they have asked, you should ready to attend the question. Question is, determine the decimal number that corresponds to the machine word. So machine word is given, it is in hexadecimal system, so we have to convert it in terms of decimal. So for what we have learnt is, given number will be in decimal, we are going to represent it in terms of a machine number which is in hexadecimal system. Right? Now reverse, we have given number is in the hexadecimal system, that is machine number. We have to determine the decimal number of the same. Now the procedure is quite different. First step is, we have to convert the hexadecimal number into its equivalent binary number. I am repeating once again, we have to convert the given hexadecimal number into its equivalent binary number. So as I already explained in the previous session of writing hexadecimal number in terms of binary, please go through that list. Now I can write 4 as in terms of binary. I can write it as 0 1 0 0. Similarly, number 5 can be written as 0 1 0 1 1. Fine. So if you are finding difficulty to write the binary number at a time, you can rewrite the given number in terms of hexadecimal. In the sense, let me write here, right from 1 2 3 4 5 6 7 8 9 A B C D E F. Fine. I'm sorry, 0 is left out. 0, 1, 2, 3. So totally you should have 16 numbers. 10 is considered as A. Anyhow, up to here I have 10. Why? Because 0 is included. 10, 11, 12, 13, 14, 15, 16. Now as I've already told you, you have to put 8 zeros first. 4, 5, 6, 7, 8 zeros. Followed by 8 ones. Next 4 zeros. 4 ones. 4 zeros. 4 ones. Next 2 zeros, 2 ones. I'm sorry, 2 zeros, 2 ones. Again 2 zeros, 2 ones. Am I correct? Next 2 zeros, 2 ones. 2 zeros, 2 ones. Next 0 1, 0 1, 0 1, 0 1, 0 1, 0 1, 0 1, 0 1. So this is what we have hexadecimal in terms of binary. Now go through this list. As per the required problem, a number 4 can be represented as 0 1 0 0. So that is what I have written, 0 1 0 0. Next, for a number 5, how can we write 5 as 0 1 0 1? So 0 1 0 1 I have written. Next, for a number D, how can I write D as 1 1 0 1? So I have already written 1. So let me write 1 1 0 1. See here, this bit is for 4 and this group is for 5 and this group is for D. Now I have to write for E. So look at the values. What we have for E is 1 1 1 0. Next for E, 1 1 0 I have written for E. Next it is for 4, 0 1 0 0. Fine. Next we have 3 sets of zeros. So 4 4 number 3 set you have to write. 4 4 zeros 3 set. Clear? So this is for the next numbers. So what I have done is, I have converted hexadecimal number in terms of binary. So let me write it once again. 0 1 0 0, 0 1 0 1, 1 1 0 1, 1 1 0, 0 1 0 0, 1 2 3 4, 1 2 3 4, 1 2 3 4. So I have converted it in terms of equivalent binary number. Now given number is in hexadecimal, we have converted it in terms of binary. Clear? Now as I already told you, in terms of single precision, where whatever the problems given for you in a machine code, that will be in a single precision format, remember. So in single precision format, first digit represent a sign, first bit. Rest of 8 bits, as I already told you in the previous session, 8 bit represents exponent, and remaining totally 32 bits, right? So 23 bits will be of Montesa. So this is what the standard format of single precision point is. Now next step what we have to do is we have to extract exponent value from the binary. In the sense, as I already told you, this first digit will be representing sign. Fine. Next 8 digits you just count 1, 2, 3, 4, 5, 6, 7, 8. So these 8 digits will form an exponent value. Remaining will be Montesa. So let me write exponent value here. So I can write exponent is 1 000 1011. I'll give you the notes of one problem. You just copy the same procedure in your notes, and whatever the problems I am going to solve for the next sessions and all, you have to copy the same procedure, but you have to write the notes by watching the video. Fine. So I have written the exponent value, that is 8-bit number I have written. Now it is in binary. Now exponent value I have to convert it into step 2 it is. I am repeating once again. Step 1, we have to write a given number into its equivalent decimal number. Step 2 is we have to write an exponent value, that is first bit will be for sign. As I already told you in the previous session, first bit will be sign. Next 8 bit will be representing exponent value. So write down those 8 bits. Remember, I am just leaving first bit. Why? Because it is sign. So remaining 8 bits I have written here, which is in binary format. Now, as you already familiar in converting binary into decimal system by multiplying it with 2 powers, right? So let me do that. When you're going to multiply it with 2 powers, you have to multiply in this order. Start with the right side and you have to end with the left side, and you have to multiply right from 2 power 0 to power of 1. So let me do that. 1 into 2 power of 0, first number, plus 1 into 2 power of 1, plus 0 into 2 power of 2. Clear? I am multiplying each and every number with increasing order of 2's. So you are already familiar in converting binary to decimal. This is what the procedure is. So 1 into 2 power of 1, 0 into 2 power of 2, next 1 into 2 power of 3, 1 into 2 power of 3, plus 0 into 2 power of 4. I'll write here, plus 0 into 2 power of 5. Next, plus 0 into 2 power of 6. Plus 1 into 2 power of 7. Fine. So it's 2 power of 0 for the first digit, 2 power of 1 for the second, 2 power of 3 for the 2 for the third digit, 3 for 4 digit, 4 for 5 digit, 6th digit it is 7. So 1 will be increasing. So in that order you have to multiply the 2 powers. Now let me simplify this. So when you are going to simplify, remember 2 power of 0 value will be 1. So any value to the power of 0 is 1. So that is how this value become 1. 1 into 1 will be 1. Plus 2 power of 1 into 1 is 2. Plus 0 into anything will be 0. So 1 into 2 cube is 8. Plus 0 into anything is 0. Next 0 into 2 power 5 is 0. 0 into 2 power of 6 is 0. Next I have to calculate 2 power of 7. Into 1 is 128. Now you just add all these numbers. 128 plus 8, 128 plus 8 plus 2 plus 1. That will give us 139. So exponent value what we have obtained is 139. Fine. So this is what step 2 is. I have extracted the exponent value from the binary numbers and I have converted the same in terms of decimal. Now whatever the obtained value we have, it is in terms of decimal. So let me write base 10. Fine. Now what we have to do is we have to compare this with, so exponent in the sense the value of C in the standard formula. So C is equal to 139. In the sense I have to subtract what is the 2 power we have in the formula. It is C minus 127, right? You just go through the formula I have given in the previous session. It is 2 power of C minus 127. But what we have obtained here is C value. Now I have to subtract it from 127 in order to obtain C value. So this I'll write this as exponent value is 139. So now I have to subtract it from 127. I'm repeating once again, whatever the value you are going to obtain in terms of decimal in step 2, you have to subtract that value and with 127. 127 it comes from the formula. First you have to write this value and 127 has to be subtracted from the obtained value. Remember, whatever the value we have obtained, you just write it in decimal. So we have to subtract 127 from the obtained value in step 2. So that is what I have done. Now when you subtract these values, you are going to get 12. That is positive, right? Remember, whether it is positive or negative, it doesn't matter. Only the shifting of the decimal points will be varying. So up to step 2, hope so it is clear. So I have obtained exponent in terms of decimal, and I have subtracted it from 127 from the obtained number, so that I have obtained 12. Next, step 3. Next is, we have to write the given number. First let me write the given problem 45 DE 4000 with base 16. Now as we are expressing it in a standard scientific notation, that is machine format number in terms of decimal, first step is, in the step 3, first what we have to do is, for a sign bit you have to put always 1. Remember, I am telling you once again, for a sign bit, no matter whether you have 0 or 1, you have to put 1 here. Don't get confused, you have to write 1. So 1 is mandatory. Whether it is positive or negative, don't worry, you have to put 1 here. Next, keep point here. And you already know that after this sign bit, we are going to obtain a what we say mantissa. So you leave this sign portion, exponent part as well as sign part. Whatever the numbers is there, we call it as mantissa. You just write those numbers after the decimal. So let me write the numbers as 1 0 4 ones followed by 2 zeros. Again 1 followed by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 zeros, which is in binary format. I'm repeating this step once again. It is a bit confusing, so that is why I'm repeating it. Since we have asked us to convert a decimal number into machine word, we have to convert. In the problem, machine word is given, which is in hexadecimal form. We have to convert it in terms of decimal form. So up to step 2 it is clear. Now what I did is, I have written a given number in terms of binary in such a way that for the first digit, no matter whether you have 0 in the sign bit or 1, you have to take 1 always. So keep a decimal point. After that you have to write the mantissa part. So after 8 bits, whatever the portion you have, as you already done in the previous session, so remaining will be mantissa. So you have to write all those numbers here after the decimal point. Fine. So this is what I have done. Clear? Now this number I have to multiply it with 2 power, whatever the C value I have obtained, you have to multiply it with 2 power of that value. Here I have obtained C value is 12, so I have written 2 power of 12. Since you have a power, positive power, so you have to shift this point in this direction. Remember, I am writing here for your reference. When you have positive power, you have to shift the decimal in this direction. When you have negative power, you have to shift the decimal point in this direction. So since you have positive power, you have to shift the decimal point in this direction. Since you have decimal point as 12, so you have to shift this decimal point by 12 digit. Count the number of digit. 1. You should not count this, since you are shifting this decimal to this side, in the sense from left to right. Why? Because you have positive sign, so you have to shift by 12 digit. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So up to here you have to write. So again, when you shift the point, this point again, no need to write. 1, 1, 0, 4 ones, 0, 1, 000. So this is what we have obtained. Whatever the remaining zeros are there, no need to write again. So you just write those number into 2 power of 12. Remember, suppose if you have 1, you may not get 1 here. After shifting the point, no ones will be left out. Only 0 part will be truncated. If ones are remain, then there will be mistake in your solution. Fine. I am repeating once again. What I have done is, I have obtained C value. After that, given problem was expressed in terms of binary number by writing a first bit as 1 followed by mantissa. We should not write, remember, we should not write exponent and sign bit. We have to write only mantissa part. I have written here. into 2 power of whatever the C value obtained I have written. If the power value is positive, you have to shift the decimal in this direction. If the power value is negative, you have to shift the decimal in this direction. Since power value is positive, I have shifted this decimal by 12 digits. So count the 12 digits. You should not count this. You have to count these values. By 12 digits, you have to count whatever the values you are going to obtain. You just write it. If you want, you can write all these zeros. So it is no need to write again. Why? Because if you further multiply anything to these zeros, you will be getting 0 only. So no need to write all these zeros. You just write this one. Clear? And one more thing, that the minute you shift this point, again you no need to write power here. I'm repeating once again. Since in this step you have not shifted the value by 12 digits, so you need to write 2 power 12 here. In second step, I have already shifted this point, so no need to write this 2 power and all. Clear? So I have a binary number which I have to convert it in terms of decimal number. So let me do the decimal transformation. So as already done, I'll write from here 0 into 2 power of 0. This bit is completed. Plus 0 into 2 power of 1. Plus 0 into 2 power of 2. Plus 1 into 2 power of 3. Plus 0 into 2 power of 4. Why I am marking this is in order to avoid confusion. 0 into 2 power of 5. Fine. Plus what we have here, 1 into 2 power of 6. Plus 1 into 2 power of 7. Plus 1 into 2 power of 8. Plus 1 into 2 power of 9. Plus 0 into 2 power of 10. Plus 1 into 2 power of 11. Plus 1 into 2 power of 12. So I have completed for all. Anyhow, when you are going to multiply 0 with any powers, again the solution will be 0. So I am not going to calculate all these things. Why? Because you have 0 multiplied with it. Fine. 0 into 2 power of 0 is 1. So 0 into 1 will be again 0. So it is also 0. Now whatever the remaining value, 1 into 2 power of 3. So 2 power of 3 is 8. So first line you are going to get 8. Plus 1 into 2 power of 6. 2 power of 6 is 64. Plus 2 power of 7. 128. Plus 2 power of 8. 256. Plus 2 power of 9. 512. Plus 2 power of 11. 2048. Plus 2 power of 12. 4096. Fine. Now let me add all these digits. We will get, I'll do 8 plus 64 plus 128 plus 256 plus 512 plus 2048. So I'm sorry, I missed one value. You just see here 8 plus 64 plus 128 plus 256 plus 512 plus 2048 plus 4096. So that will give us 7112. Fine. So 7112 I have written here, which is in decimal. Fine. So this is what we have to find. So I'm just revising once again. See here, step 1, we have to write given hexadecimal number in terms of binary, as I already told this method in this previous session. Please go through that. I have written it. So remember, first digit is in a single precision. It is first bit is for sign, followed by 8 bits is for exponent. Fine. So in the next step, what I have done is I have written all the exponent values, that is 8 bits, whatever we have written here. So 8 bits I have written here as an exponent value. Now I have converted the binary number. Exponent is in binary. So I have done it. I have converted it in terms of decimal by multiplying 2 power of 0. So this is what I have obtained. Now exponent value we have to subtract it with 127. Why? Because we have in the formula 2 power of c minus 127. In order to equate, I have subtracted it with 127. So I have obtained 12. Anyhow, it is positive. So if it is positive, you have to shift the decimal in this direction. If it is negative, you have to shift the decimal in this direction. This is only for your reference. Since it is positive, before writing that, let me write step 3 as given number hexadecimal number can be written as sign bit will be 1. Whatever may be the sign, whether it is positive or negative, whatever may be the bit you have here, you have to write 1 always here. 1 point. Remaining after 8 bits, remaining will be Montesa. So whatever the Montesa I have here, I have written the same here also. Into 2 power of this exponent value I have written. Fine. In the next step, I have shifted this point by 12 digits. Why? Because it is positive, I have to shift in this direction. I have counted the 12 digits and I have kept the point here. Since after that I have only zeros, I cannot write. If you want, you can write, but I am not going to write here. So I have removed all those zeros and I have written it in binary form. So the minute you have shifted this decimal, no need to write this exponent value. So leave it as it is. Since it is in binary, we have to convert it in terms of decimal. Now we can do the same procedure by multiplying 2 powers from this in this direction. You are going to get the value this. So this is the required decimal number, which is the required answer for us. That is what they have asked, right? So decimal number we have to find out which is corresponding to the given word. So this is the required decimal number. Hope so it is clear. Now let me solve one more problem based on the same concept so that you will understand well. So here is a second question for you. Since it is in decimal format, we have to find out it in this is in hexadecimal format, that is machine number. We have to convert it in terms of its equivalent decimal number. First step, as I already told you, step 1, write it in binary format. So how can we write 4 in a binary format? As I already told you, 0 1 0 0. We just go through that list, you will understand this. So 5 can be written as 0 1 0 1. Similarly, 6 can be written as 0 1 1 0. Next, 0 can be written as 4 zeros. Fine. 7 can be written as 0 1 1. Next 3 zeros we have. So 3 pairs of 4 zeros. 1 pair, 2 pair, 3 pairs. So this is what the required binary number is. So step 1 is completed. We have converted this. So in this number, first digit will be sign bit. Fine. Remaining 8 bits in the sense 1, 2, 3, 4, 5, 6, 7, 8. So these 8 bits represent exponents. Fine. Now in the step 2, I am going to convert the exponent value in terms of binary. So let me write the exponent. Exponent value, what is the binary? Exponent we have 1 followed by 3 zeros, 1 0 1 0, which is in binary. I have to convert it in terms of decimal. So let me convert it in terms of decimal. I can write this as 0 into 2 power 0 plus 1 into 2 power of 1, 0 I have written. So this digit is also completed, plus 0 into 2 power of 2 plus 0 into 2 power of 3, 0 2 power 0, I'm sorry 1, right? 1 into 2 power of 3, so this digit is completed. Next 0 into 2 power of 4 plus, I'm writing here, plus 0 into 2 power of 5. See here, 0 2 power 0, 2 power 1, 2 power 2, 2 power 3, 2 power 4, 2 power 5, plus 0 into 2 power of 6 plus 1 into 2 power of 7. Clear? If you are finding confusion, you just tick the numbers whatever you have already completed multiplication. So 0 terms I am not going to calculate. Why? Because when you are going to multiply it with 0, no terms will be there. So this is also not there. Fine. Whatever I have obtained is 2 cube is 8 plus 2 power of 1 is 2 plus 2 power of 7. 2 power of 7 is 128. So this is what I have obtained. So let me calculate 128 plus 2 plus 8 will give us 138. So let me write it as 138, which is in decimal form. Exponent value I have obtained in decimal form. Now as I already told you, I have to subtract it from 127. Why? Because all the problems in your syllabus will be in single precision format. So let me subtract. To obtain C value, I have to subtract 127 from 138. So when you subtract 127 from 138, you will get 11 as an answer. So C will be 11. You just subtract the value, obtained value with 127, you will get C as 11. In this case also it is positive. So as I already told you, when you have positive, you have to shift the decimal in this direction. Clear? Now let me do step 3. So step 3 is, we have to write a given number. Let me write given number 4560700, with base 16 can be written as, first number I have already told you, it is sign bit. No matter whether we have 0 or we have 1, whether we have positive or we have negative, you have to write it as 1. 1 point Montesa remaining part. After the exponent, whatever the part you have, it is Montesa. You just copy down. 11 followed by 1, 2, 3, 4, 5, 6 zeros. 1, 2, 3, 4, 5, 6 zeros. Followed by 111. Followed by 3 pair of zeros. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. It is in binary. Into 2 power of 11 I have to write. Clear? Now I have to shift this decimal to 11 digits in this direction. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So your decimal point here shifted to this place. So let me write it. So here no need to write again decimal. I have already I am shifting this in this step only. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Yes. 311. So I have already converted. No need to write it in 2 power of 11. Now it is in binary. In the last step, we have to convert it in terms of decimal, equivalent decimal value, right? So let me convert this number into equivalent decimal value. 1 into 2 power of 0 plus 1 into 2 power of 1 plus 1 into 2 power of 2 plus 0 into 2 power of 3 plus 0 into 2 power of 4 plus 0 into 2 power of 5 plus 0 into 2 power of 6 plus 0 into 2 power of 7 plus 0 into 2 power of 8. I am marking this only for your reference. Plus 1 into 2 power of 9 plus 1 into 2 power of 10 plus 1 into 2 power of 11. So this is what I have obtained. Anyhow, I am not going to calculate all the numbers which contain 0. Why? Because after simplification also you will get 0. So these terms I am not going to calculate. Why? Because I have zeros in that place. Clear? Now what I have? 2 square is 4 plus 2 power of 1 is 2. 2 into 1 is 2 plus 2 power of 0 is 1. 1 into 1 is 1 plus 2 power of 9 I have to calculate. 2 power of 9 is 512 plus 2 power of 10 is 1024 plus 2 power of 11 2048. Clear? Now let me add all these numbers. 4 plus 2 6 plus 1 7 7 plus 512 plus 1024 plus 2048. So that will give us 3591. 3591, which is in decimal number. Clear? So given a number which is in hexadecimal machine number, I have converted it in terms of equivalent decimal number. First step, I am repeating it once again. Step 1, we have to write equivalent binary format. As the given number is in hexadecimal, we have to write it in the binary format. Next, first digit will be for sign, next 8-bit will be for exponent. As I already explained this concept in the previous videos, you just go through that. So that is why I have written the exponent digits here. So after one digit, count 8 digits, you have to write here. Convert it in terms of decimal by using this procedure, and then subtract the obtained value with 127. You will get C value. If it is positive, shift in this direction. If it is negative, shift in this direction. So since here I have a positive value, I have shifted this decimal. For the first time, you have to write it as 2 power of 11. Once you shifted this value, no need to write this. So I have done this, which is in binary. Since we need it in decimal format, so I have applied the same procedure to convert it in terms of decimal number. So this is what the required number is. Hope it is clear. Now let me do one more problem where we have obtained a negative C value, exponent value, so that you will understand very well. Here is a problem. Suppose if I have a problem BA 3940, which is in hexadecimal. Steps are as usual. Nothing will be changes there. So BA 3940 in hexadecimal they have given. Step 1, we have to write it in equivalent hexadecimal. So as I already told you, hexadecimal number, you just keep the list with you. You just keep on writing 1011 for B. Next for A, 1010 for A. Fine. Next for 3, it is 0011. For 9, 1001. Next we have zeros 1, 2, 3, 4. So 4 pair of zeros. 1, 2, 3, 4 pair of zeros I have written, which is in binary format. already I have told you this is sign bit. Anyhow, we have 1 here, it doesn't matter. Next 8 bits, 1, 2, 3, 4, 5, 6, 7, 8. These 8 bits corresponding to exponent value. Remaining will be Montesa. Fine. Now step 2, let me calculate. Let me write the exponent value. Exponent is what we have: 0, 111, 0, 1, 00, 1, 2, 3, 4, 5, 6, 7, 8 bits, which is in binary. We have to convert it in terms of its equivalent decimal number. So 0 into 2 power of 0 plus 0 into 2 power of 1 plus 1 into 2 power of 2 plus 0 into 2 power of 3 plus 1 into 2 power of 4 plus 1 into 2 power of 5 plus 1 into 2 power of 6 plus 0 into 2 power of 7. So I am not going to calculate 0 terms. As I already told you, 0 multiplied with any number will be 0. So what I have obtained is 2 power of 5 is 32 plus 2 power of 4 is 16 plus 2 square is 4 plus 2 power of 6 is 64. So let me add all these numbers: 32 plus 16 plus 4 plus 64. So this will give us 116. Clear? Now 116 I have obtained. It is exponent value. Fine. Now I have to subtract. To obtain C value, I have to subtract it with 127. So as I already told you, it is by formula. So 116 minus 127 will give us minus 11. Fine. Here in this case I have obtained negative exponent value. Anyhow, procedure will not be changing. Only shifting decimal point will be in this direction, since it is negative. If it is positive, it will be in this direction. Since it is negative, I am using this direction of shifting. Now step 3. Let me write the given number BA3940 with base 16 as first digit. No matter whether it is negative or positive, first digit should be taken as 1. 1 point. Next digit will be Montesa. Leaving exponent value, whatever the values you have, you just copy down. 0, 111, 001, followed by 1, 2, 3, 4 pairs of zeros. 1, 2, 3, 4. 1 pair, 2 pair, 3 pair, 4 pairs of 0 into 2 power of minus 11 I have to write. Now this is very important step. Now what we have to do is we have to shift this decimal in this direction. Why? Because I have negative power, right? And moreover, what we have obtained here is negative. So I have to take negative sign for this given number. Remember, I'll put negative sign here. So you have to take negative. Why? Because C is negative. Put negative sign here and shift the decimal by 11 digit. Let me shift the decimal here. So by 11 digit I have to shift. First digit you write as it is. Shift by 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Now you keep point here 0. Clear? I am repeating once again. Since we are shifting the decimal digit, why? Because we have obtained negative sign, I have to shift in this direction. 1 digit I have already moved. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Let me count once again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 12 digits I have moved. So only 11 digit I have to move. Keep the point here. Fine. So only 11 digit I have to move. I have moved by 11 digit. If you want, you count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 digit I have moved. Keep the point, and remaining whatever the numbers you have, you join with this 0, 11, 1, 001. Again, no need to write all these zeros. Fine. Since I have shifted this decimal, no need to write 2 power of minus 11 also. Hope so it is clear. Right? Now let me write whatever the value I have obtained. Remember, I have not changed this decimal by 0. I have taken 1, but this 1 comes to this place. Why? Because I have shifted this decimal to left side by 11 digits. So that is what I have obtained. Minus 0.1234567891 11 digit. Again 0111001 in binary. Fine. Now we have to convert it in terms of decimal. Clear? Keep in your mind, since you have negative, you have to put negative sign here. To convert it in terms of what we say, decimal number, remember it is very important step. Since you have decimal number here, so you are going to multiply, start with this number. In the sense, this number will be of the form 0 into 2 power of 0. Fine. Since you don't have any number after this, so only you have 0. Suppose if you have to do 1 into 2 power of 0. Next you have point. So you have to add, see here you have to multiply 2 power of 0 for this. For this number you have to take 2 power of minus 1. Why? Because it is fractional part. You have to convert after the decimal point, whatever the number is there, we have to convert it in terms of decimal by multiplying it with negative powers. You've already converted all these number system in your computer science subject. So same concept you have to apply. 2 power of minus 1. So 0 into 2 power of minus 1 plus 0 into 2 power of minus 2, 2 power of minus 3, 2 power of minus 4, 2 power of minus 5, 2 power of minus 6, 2 power of minus 7, 2 power of minus 8, 2 power of minus 9, 2 power of minus 10. So up to 2 power of minus 10 you are not going to get any digit. Why? Because all the digits are 0. Plus I can write this as 1 into 2 power of minus 11 plus 0 into 2 power of minus 12. If you want you can write all these things, but since anyhow it is 0, so I am not going to write it. 0 into 2 power of minus 12 plus 0 into 1, right? So 1 into 2 power of minus 13 plus 1 into 2 power of minus 14 plus 1 into 2 power of minus 15. Next again 0 I have plus 0 into 2 power of minus 16 plus 0 into 2 power of minus 17 plus 1 into 2 power of minus 18. Again whatever the zeros term I have, I am not going to simplify all those numbers. So I just mark it out. So again these values will be 0. Now let me write one more step. What I have obtained is minus 1 into 1 by 2 power of 11. Meaning of 2 power of minus 11 is 1 into 1 by 2 power of 11 plus 1 into 1 by 2 power of 13 plus 1 into 1 by 2 power of 14 plus 1 into 1 by 2 power of 15 plus 1 into 1 by 2 power of 18. So this is what I have to calculate. Let me keep negative sign as it is. Now let me calculate 1 into anything will be 1, that value will be same. So 1 by 2 power of 11 I have to calculate. 1 divided by 2 cap 11. See here you have to calculate like this. 1 divided by 2 power of 11. 1 divided by 2 power of 11. So that will give us this value. Since you are going to get it in exponent in terms of 10 power, so if you are writing all those terms, it will become elaborate. Instead you just add with the rest of the values. Plus 1 divided by 2 power of 13. See here 1 divided by 2 power of 13. Next plus 1 divided by 2 power of 14. 1 divided by 2 power of 14 plus 1 divided by 2 power of 15. 1 divided by 2 power of 15 plus 1 divided by 2 power of 18. Fine. Now let me write the final answer. If you want you can write it for each and individual term, but it will be elaborating like in terms of 10 powers you are going to get. Instead of that I have ordered all the terms, so you are going to get it as 7.05718 into 10 power of minus 4. I am not going to write all the digits, it's your wish, so I have written only a few digits into 10 power of minus 4, which is in decimal system. So this is the required number to us. Procedure is same, only difference is here I have obtained a negative sign. So when you have negative sign, I have to shift the decimal in this direction. So shift this decimal by 11 digits. So let me shift 1 I have written here. I have written rest of the 11 zeros. Keep the point again 0. So I have written the same here, and I have copied the same. Since it is in binary, I have to convert it in terms of decimal. Here it is important. Why? Because it is decimal number. For the first number you have to multiply by 2 power of 0. Suppose if you have one more term, say 1, you have to multiply it with 2 power of 1. Fine. So see, in this problem I don't have any number, so I have to power of minus 2. So you have to multiply in that order. After simplification, I have obtained this, which is in decimal. And moreover, one thing you have to remember that when you have obtained C value negative, you have to put negative sign for a obtained decimal number. So this is the required decimal number. Clear? Hope so this concept is clear for you. If you have any doubts, you can free to ask me in the next session. You just go to this video. After clarification, I'll give you homework problems which has to be solved in the notes, and continue in the next session. Thank you.